In this video segment, we shall deal with a very important topic, which is Laplace transform. Now, Laplace transform is a topic which is covered in engineering mathematics as well as in degree mathematics. It is one of the most used transforms, which is not only used to convert a given function f of t from time domain to s domain, but is also used to solve differential equations, is also used to solve electric circuits, and so on and so forth. And we shall see that when we deal with problems related to applications of Laplace transform. Now, how do we define a Laplace transform? Now, if I have a function f of t which is defined for t greater than or equal to 0, then the Laplace transform of the function f of t is equal to 0 to infinity e power minus st f of t dt. So this is what you need to remember. To obtain the Laplace transform of a given function f of t, which is defined for t greater than or equal to 0, is equal to 0 to infinity e power minus st f of t dt. That means we are multiplying the given function f of t with the integral e power minus st and integrating it within the limits 0 to infinity. Now let us find the Laplace transform of 1, e power at, e power minus at, and Laplace transform of t power n in this lecture, and solve a few problems related to these formulas. Now what is Laplace transform of 1? That means f of t equals 1. So Laplace transform of 1, so we call it as L of 1 equals 0 to infinity e power minus st into 1 dt. So I have to integrate e power minus st, which is e power minus st divided by minus s within the limits 0 to infinity, right? So I have, so this is minus 1 by s e power minus infinity minus e power 0. Now we know that e power minus infinity is 0 and e power 0 is 1. So we get this as minus 1 by s into minus 1, which is equal to 1 by s. So let us list out. Laplace transform of 1 is 1 by s. The next one, so this is the first one. The next one, let us consider to find the Laplace transform of e power minus at. So once we find e power minus at, we'll also know what is the Laplace transform of e power at. So this is equal to 0 to infinity e power minus st. What is f of t? E power minus at dt, which is 0 to infinity e power. So we know that e power m into e power n is e power m plus n. So let's take minus sign common. So you have s plus a into t dt. So I integrate e power minus s plus a into t, which is e power minus s plus a into t divided by the constant term s plus a with t varying between the limits 0 to infinity, right? So with a minus sign, of course. So you have minus 1 by s plus a. When t is infinity, you get e power minus infinity minus e power 0. So e power minus infinity is 0, e power 0 is 1, so you get minus 1 by s plus a into minus 1, which is equal to 1 by s plus a. So therefore, Laplace transform of e power minus at is 1 by s plus a. So remember, if this is negative, if a is negative, then this becomes positive. So similarly, what is Laplace transform of e power at? It is 1 by s minus a. So let us find the formula of the next one. You have Laplace transform of t power n. Now this is a very important formula. So this is equal to 0 to infinity e power minus st. So instead of f of t, I have t power n dt. Right? So now what do? We have to use a substitution. Let me put st equal to x, right? So therefore dt is equal to dx by s, right? So therefore if s varies from 0 to infinity, x also will vary from 0 to infinity. So as s varies from 0 to infinity. So you have 0 to infinity e power minus x. So st is equal to x. What is t? T is x by s. So t is x by s whole power n, and dt is dx by s. So this is 0 to infinity e power minus x power n. Here you have s power n into s dx. So what is s power n into s? It is s power n plus 1. So you have 0 to infinity 1 by s power n plus 1. I take it outside the integral. E power minus x into x power n dx. Right? So you have e power minus x power n dx within the limit 0 to infinity, and this is nothing but gamma n plus 1 divided by s power n plus 1. So what is gamma n plus 1? It is n factorial divided by s power n plus 1. So therefore Laplace transform of t power n is n factorial divided by s power n plus 1. Now using these formulas, let us solve a few examples. The first one, f of t equals 2t cube plus 4t square plus 3t plus 8. Right? So we need to find the Laplace transform of f of t. So this is 2 into Laplace transform of t cube plus 4 into Laplace transform of t square plus 3 into Laplace transform of t plus 8 into Laplace transform of 1. So we have the expression Laplace transform of t power n is n factorial s power n plus 1. So this is 2 into n is 3 here, 3 factorial divided by s power 3 plus 1, which is 4, plus 4 into n factorial, 2 factorial divided by s power 2 plus 1, which is 3, plus 3 into 1 factorial divided by s power n plus 1, which is 1 plus 1 equal to 2, plus 8 into 1 by s, because L of 1 is 1 by s. So what is 3 factorial? Is 6. 6 into 2 is 12 into s power 4 plus 2 into 4 is 8 by s cube plus 3 by s square plus 8 by s. So this is Laplace transform of f of t. Second example, f of t equals 0 for t varying between 0 to 3 and 4 for t varying between 3 and infinity. Okay, so now I need to find the Laplace transform of f of t. So Laplace transform of f of t equals, so here for the limit 0 to 3 it is 0, right? So you actually have the Laplace transform function which is 0 to infinity e power minus st f of t dt. So I'm going to split the integral within the limits 0 to 3. So as t varies from 0 to 3, f of t is 0, so it is 0 plus 3 to infinity. So what is f of t? It is 4. So it is 4 e power minus st dt. So this is of course 0. So you have Laplace transform of f of t, which is 4 integral e power minus st within the limits 3 to infinity. So this is 4 into e power minus st by minus s varying between 3 and infinity. So you have minus 4 by s e power minus infinity. So s into t, t is infinity, so you get infinity here, minus e power minus 3s. So e power minus infinity of course is 0, right? So this is 0. So you get minus 4 by s into minus e power minus 3s. So minus into minus is plus. So therefore the answer is 4 by s into e power minus 3s. f of t equals t minus 2 whole square for t greater than 2 and 0 for t varying between 0 to 2. Okay. So now let us try to split the integral. So you have Laplace transform of f of t, right? So 0 to 2 it is 0, plus 2 to infinity it is t minus 2 the whole square e power minus st dt. So I have to integrate this. You consider this is the first function, this is the second function. So how do you integrate? So 2 to infinity, you have two terms, t minus 2 whole square into e power minus st dt. So this is first function, t minus 2 the whole square into integral of the second function, which is e power minus st by minus s, minus integral of the second function, which is e power minus st by minus s, into differential of the first function, which is 2 into t minus 2 dt. Okay, so of course you have the limits varying between 0 to 2 to infinity, which we shall substitute later. So this is t minus 2 the whole square by minus s e power minus st. So minus into minus is plus, so you get plus 1 by s, right? So again this is t minus 2 into e power minus st dt. So again this is the first function and this is the second function. So you get plus 1 by s first function into integral of the second function, which is e power minus st by minus s, minus integral of the second function, which is e power minus st by minus s, into differential of first function. Differential of t minus 2 is 1 dt. So this is again, so this remains as it is, plus 1 by s t minus 2 into e power minus st by minus s, plus 1 by s into integral of e power minus st is e power minus st by minus s, right? Brackets. So you have t minus 2 the whole square by minus s e power minus st. So now 1 by s into, so this is 1 by s and this is minus s, so I get minus 1 by s square t minus 2 into e power minus st, right? So here you have minus s square into s is minus 1 by s cube e power minus st, right? So this with t varying between, you have 2 to infinity, so 2 to infinity. Infinity first, so let us substitute t equal to infinity. So you have e power minus infinity, which is 0. Here again you have e power minus infinity, which is 0, e power minus infinity, which is 0, so you get 0, all the three terms, minus, I am putting t equal to 2, so 2 minus 2 is 0, 2 minus 2 is again 0, so you get minus 1 by s cube e power minus 2s. So what is the final answer? The final answer is e power minus 2s divided by s cube into, I have a 2 somewhere here which I have missed out, so you have a 2, isn't it? So 2 is here, so you get 2 outside, so this is 2, okay, so you get a 2 here and a 2 here, so you will also get 2 here. So it is 2 into e power minus 2s by s cube. Example 4, f of t equals e power t for t varying between 0 and 1 and 0 for t greater than 1. Right, so this is nothing but Laplace transform for f of t equals 0 to 1 e power minus st into e power t dt plus 1 to infinity, it is 0. So this is 0 to 1 e power minus, so if I take t outside, all right, so you have e power minus st, so you get s, and then you have plus t, so I have minus 1, right? So minus st, minus into minus is plus, so you get plus t dt. So this is e power minus s minus 1 into t divided by minus s minus 1 within the limits 0 to 1. So I have 1 by minus s minus 1, right? Put t equal to 1. You get e power minus s minus 1 minus e power 0. So this is e power minus s minus 1 minus e power 0 is 1 divided by, can I write this as s minus 1 with a minus sign? Yes. So if I multiply this expression by minus sign, I get 1 minus e power minus s minus 1 divided by s minus 1. So in the next lecture session, we shall see how we can find the Laplace transform of trigonometric functions and hyperbolic functions. And then we shall also solve the problems related to sine, cos, sine hyperbolic and cos hyperbolic. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads. And thanks for watching.